Well, hello. I'm deeply honored to be with you all here today in this magnificent structure. And my hat is off to Michael and to Jesse, the conference organizers, for putting together what is really a fearsome lineup with fearsomely smart and interesting people. And I'm consequently feeling a little bit of fear, feeling like the discount lunch meat in the middle of a $3 million sandwich of tasty goodness. So I'm here to offer you 30 minutes of acute disappointment. We're going to talk about computers. We're going to talk about fictional computers. We're going to talk about real-world computers. But let me kick off the disappointment by doing something you should never do, which is to talk about the title itself. Michael had asked all of us to talk about the future, to think about the future, and maybe even to use the word future in the title. And I had originally written the future of the interface is the future of the computer, and that's true. That is apparently the purpose for my being on the planet. That's what I'm pursuing. But then I started to realize, well, that's not just true in the future. It's always been true. And we'll take a look at why that is and why it's important to pursue things in that vein. But I'm really excited to be here because the word compute is in the title of the conference. And that doesn't seem weird to you, and it doesn't seem weird to me. But to most of the rest of the world, the word compute and the word computer has gone out of favor. And in just a minute, we'll see why that is and why we should care about it and why we should be a little bit worried. I'd like to offer as a kind of set of brackets around the entire talk a notion of location, here versus there. Where's your attention? Where's your stuff? Where's the stuff that you own? Where's the stuff that you think about? Where is your cognitive state? So as we go along, please try to apply this metric from time to time, see how we're doing. I'm actually wearing one of Jeff Hagins' collars, and if you decide no, then he can give me a shock at the end. You've got the beeper, right, Jeff? So this is a computer. It actually happens to be my own 1979 Apple II Plus. It's an amazing device. It is, in a sense, a gift as an object. It's an object of pure potential. But the thing I want to focus on here today is the here-ness of this computer. When you use this computer, whatever you're doing, you're playing Choplifter, you're editing a spreadsheet, whatever it is, your stuff is here, literally under your fingertips. There's no ambiguity about it. If it's not in here, then something's gone wrong, and it's not anywhere. So it's here or nowhere. Let's flash forward 35 years and take a look at the products made by that same company. Here's 2/3 of the kind of current product ecosystem made by that company. Actually, Chris had a beautiful slide that showed some of these devices over here and a giant server farm. I'm sorry, not a server farm, a cloud over here. And what I'm here to talk about today is the stuff in the, yes, it's right. Where's my stuff? It's in the cloud. Sounds damp. No, it's just a server. Anyway, what I'm here to talk about is the stuff that's in the middle, the opportunity that's created by this moving over here and this moving over here, because we used to live here, and we might gain value from moving back. So this is interesting, because at the time that the company that makes these devices started to get really serious about them, it removed what from its name? It removed the word computer. So we don't like computers, and maybe we're right not to like them. Clearly we don't like them so much that, again, we've banished them to the cloud. But as I say, there's an opportunity available, an opportunity to say, well, what could we put? Yeah, computers are kind of clunky. It's a clunky word, but what could we put there that would make them be worth caring about again, worth cuddling, and loving? And that's an opportunity because that's a vacuum. There's a computer-shaped hole in our world now, and what could we put there? My thesis is that we need to put something that is radically more capable, something that gives you more efficacy, more agency, more power, something that is an amplifier for your own human intent. And that can only happen as an exercise in user interface. The UI is what you have. It's all you have. There can be as much Hadoop back here and as much other stuff over here as you want. But at the end of the day, you get the UI. So I think there's a lot to be done, a lot of work to be done, a lot of value to be created by answering that question. And to do that, we need to back up. We need to back up to 1984, which was the last time that a massive change in UI happened, and in a professional sense. This, of course, is the Macintosh, and we can argue about whether Xerox PARC actually invented this stuff or not, but it's inarguable that it went into the world in this form. This is when the world got the GUI, and we replaced the one-dimensional command line with text coming in and text coming out with pictures, something that's much more innately human. And ironically, this stuff was treated and written about as a toy. Byte magazine back in 1984. This is a toy, right? Yeah, it's fun for making some pictures, but you would never use it to work on a spreadsheet or perform some kind of database analysis or, engineering task. Well, today, this is all we use. In fact, we still use this today. This is the best we have. The screen's bigger, there's more pixels, there's a network, there's all this stuff, but it's this UI still. So that, again, is an opportunity for improvement and change. And the biggest lever we have right now is to build a better UI. So let's talk, because it's inevitable, about Minority Report. This was an interesting opportunity, in a way, to undertake a certain kind of prototyping, to undertake prototyping for real-world ideas in the context of a fictional world. And it's a very rare opportunity indeed, because the film enjoyed an unusually long pre-production cycle, and it enjoyed protection from and money from Steven Spielberg, which is always a useful thing if you can get it. And more than anything else, it enjoyed the ideas of Alex McDowell, the world's most amazing production designer. And when Steven Spielberg said to Alex, I want you to build me a 2054 Washington, D.C. that looks so real because people can clearly tell that it's extrapolated from the technology world we have today and the social world and the political world and all of that, that people forget that they're looking at a kind of bunch of gadgets and a future. They want to, the audience should just believe that this is the future, and then the story can unfold unhindered by that. So Alex went at it like nobody ever has before. He uses a process called world building, in which the goal is to sort of design about 100 times more universe than the film can ever actually consume or wander through. And in fact, Alex was hired as the designer the same day the writer was hired, so there was no story at the beginning. We knew that Spielberg would need to literally be able to turn his camera in any direction. Literally, to see, which means there's no back to the set. You have to be able to go anywhere. And figuratively, in the sense that if the story needed to go somewhere else, we had to be able to answer the questions. Well, the story wasn't going to go in a subway. Now it's in a subway. What does that look like? What are the technologies? Do people make eye contact? Are they wearing Google Glass? Whatever. We had to have those answers for anything that might be asked. And to do that, we did an enormous amount of research, an enormous amount of synthesis, and we put together what was called the Minority Report Bible. Atlas might actually be a better name, but it's the Minority Report Bible. And as you can see, at the beginning of the process, we were going to be set in the year 2080. As it happened, Spielberg later felt that that was too much of a reach, and he's right, because it's only been 10 years and we've already invented everything in the movie, except for the psychic precog kids, but we're working on that. So in the Bible, we collected all of these ideas, ideas about what the future would be like, not just technology, everything. We were saying that internal combustion engines had been outlawed, so we'd fixed the ecological problem. That has immediate consequences for urban planning in cities. Cities need to be taller. That in turn has consequences for various elements of our lives, transportation and so forth. How do you make a car that can both take you to work but also drive up your building, which is 400 stories tall, and so forth. Domestic technologies, advertising technologies. Here's a cooking surface that can be alternately hot and cold. It's sort of a universal food preparation surface. Personal information technologies. That's looking a little familiar. Here's the maglev cars that drive up and down buildings. Here's the flying car that science fiction's been promising us forever, and we're never going to get it, ever. But that's fine. Just more disappointment for you. The precogs, and of course, 100 times more stuff than can fit in a movie, which means that there's 99% of these great ideas that don't make it in. This is one of my favorites. These are paparazzi bots. So they would fly around to crime scenes and sporting events and literally jostle with each other physically for visual access to information. Yes, the future is just new kinds of annoyance. So Steven downgraded us from 2080 to 2044, which is a better guess at how far you even could propose to predict. And then at the very last minute, and I don't know why, I need to get someone to tell me, we got upgraded to 2054, so there was an enormous scramble and redubbing of lines so that the calendar math would work out, and if you look closely, you can see it. I was responsible for all of the technology, that is to say, not for inventing all of it or finding all of it, but for seaming all of it together. A believable future has to feel like it evolved together, not as a bunch of disparate pieces that got jammed together at the last minute. And that's interesting. The single biggest responsibility, of course, was this. Spielberg wanted to know what computers looked like in the future. He said quite presciently that he did not want to see mice or keyboards, and thank you, Stephen, for that. Enough is enough already, let alone in 2054. And voice recognition, yeah, but nothing is quite so uncinematic as voice recognition. You can't see it no matter what it does. So he loved the idea that we proposed to him that his actors, or the characters in the movie, could literally stand in the middle of a vast array of images, giant screens, who knows how many, and conduct as if they were Mickey Mouse on the promontory in Fantasia, or Stokowski conducting an orchestra. And by using these sort of natural-seeming human gestures, collate and sift through the mountains of data that were coming out of the precogs. So we went at it, interestingly, not as if it were a film design project, but because I'm an engineer and a geek and all that stuff, we went at it as if we were going to have to build a product. Which means going deep. It means going deep. It means doing lots of research. And we published the result of all of this work in various forms, in dictionaries or thesauri, like this one, that lay out the gestural language that we'd synthesized. We handed these around to the actors and the director and the producers. And then we did something even more important. This was just on the cusp of when computer graphics modeling and rendering programs became rapidly and easily and cheaply available. So you could actually prototype ideas, UI ideas, for no money. So this doesn't look nearly as polished, of course, as the final film, but this was an incredibly important document in the prehistory of the film. So this showed what it could look like. And of course, you know how you would make this. You stand out in the backyard and you film yourself from a 45-degree angle so that you look like a little kid, and you don't do that again. Then you use the choreographed gestures that you've put together and back out the motions through the scene that you then render in composite and computer graphics. And this was the moment at which the film, and especially the director, knew that they would not have to apologize for these scenes. We've seen this kind of idea in various other movies, which we won't name, and the way that those always go down is this. The director says, oh, we have to shoot the gestural computing scene. We'll have Ben Affleck wave his hands around and we'll figure it out later. And of course, you don't get anything real looking out of that. What interestingly happened is that after we showed this to the director, he knew that we could use this fictional future technology not just as some eye candy, but actually to advance the plot. We could invest this idea with narrative propulsion and help to use it to tell the story. And so we started practicing. The actors rehearsed for days and days and days. And even though when it came time to film, there was nothing on the big plastic screens, they were inert, and all the stuff would be added later by VFX companies and ILM and who knows who else. They're actors, they can use their imagination, and they knew this gestural language. So when the director said, okay, for the next scene, we want Anderton looking out the reconstructed crime scene window, and he's going to see some architectural details. That's how he'll figure out where in the city it is. We want him to pull back and pan down, and there's the bloody scissors or the murder weapon or whatever. And the actors could instantly translate that into this new language that they'd learned. And the result, when you put all that together, is something that has an incredibly high level of verisimilitude. It looks like something's happening. It looks like he knows what he's doing, and it looks like he's an expert at it. And audiences reacted very, very strongly to these scenes. So strongly, in fact, that we kind of felt like, well, maybe we should build them for real. And that's another story that we'll get to in a minute. But Stephen was so encouraged by the results that he added extra scenes. He commissioned extra scenes to be written so that Colin Farrell and Neil McDonough could also use this fictional new technology and move the story forward in other ways. And I think we'll probably cut to that in a second. We'll see some of those other actors. Who do we have here? Looks like Neil McDonough. Very nice man. So we'd given birth, in a strange sense, in a fictional setting to a real-world technology, and kind of without meaning to, we'd hijacked the entire Hollywood filmmaking apparatus and instead turned it into what might arguably be the world's largest focus group or user test. Because how many? Tens of millions or hundreds of millions of eyes saw these ideas and reacted to them. And you can imagine that we sat in theaters and watched audiences watching this movie to see how they felt about all of it, but especially about the gestural computing stuff. And the results were indeed encouraging and formed the basis of a young company called Oblong Industries. But there was actually a more important lesson buried in the movie, and it was intentional, but it was very quiet. But we decided for thematic and metaphorical reasons that we would put display everywhere in the film. We were saying in this future that we're depicting, there's display everywhere, there's pixels everywhere, there's giant displays, tiny displays, there's the specialized one, which kicked it all off, but there's also display on clothing. There's display in little personal artifacts. This didn't make it into the film either, but I love the idea of an info switchblade that you can pull out, and who knows what you do with it. There's info display, webbed finger stuff. There's display bracelets with just enough display area for a shopping list, let's say. The hand taco was a kind of communicator you could pull off your wrist. There was a deleted scene with a giant fashion show where all of the clothing would kind of redisplay what was happening in the world, and of course the cops smashed through it and ruined everything. Medical imaging displays, city-sized displays for wayfinding, for signage, and for advertising, and display for entertainment. So we were saying this is a world that's filled with pixels. And as it happens, we've already now built that world for ourselves here in the real world. And I think that's a fantastic thing, in fact. There are now displays uncountably everywhere. We're all carrying at least one with us, sometimes many more than that. And we put them on walls, and we project them at enormous scale, and they're in every place and in every format imaginable. And I think that there's a kind of logical induction that you can perform starting with that basis. So this is now true. This is axiomatic. We have a world filled with pixels. What do we want out of that world? I would say that we want it to be the case that, that the stuff we care about, our data, our applications, our communications, doesn't stop at the boundaries of the physical device anymore. It should be the case that if you're near other pixels and you've got more work to do or more gaming to do or more whatever to do than can fit on here, it should flow onto there. And they should be connected cognitively and logically and graphically. Now, if that's true, if that's to be true, then by definition, they're not running on the same processor. They're not running on, it might be from a different manufacturer altogether. It's probably running on a different OS. It might be written in a different language. But somehow, we've got to coordinate all that stuff so that an application can actually run across these different devices and support the cognitive result that you feel like it's a single, coordinated, monolithic application. That, in turn, of course, means that they're not running off the same graphics card. That, in turn, means that what we need is a distributed operating system, a new kind of operating system that thinks about space, that thinks about pixels, that thinks about display, and that thinks about humans, that doesn't restrict its thoughts or its attention to a single box, and that can run as a kind of federation of many independent processes that nonetheless cooperate and collaborate. And that's what we call GSpeak. So it's Oblong's distributed operating system. We call it a spatial operating environment. And when you write programs in GSpeak, they can do the kinds of things that I just described. So we're moving from the fictional world now to the real world. And I'd like to very rapidly go through 4 principles. They're kind of design principles or philosophic principles that we use at Oblong when we design systems, when we build systems on top of GSpeak to get work done. And let me back up just for 1 second to the slide that said professional computing. Work is important. We all have to do work. But the direction that the world's attention has gone, like this, and your tablets, isn't really about work. You can't actually, perform heart surgery or brain surgery or design a bridge or perform 40 years of mutual fund analysis very well on one of these things. It's just not meant for that. It's a beautiful device, and we don't want to get rid of it. But again, we need to fill in that computer-shaped vacuum in the middle. And the metric for that is work. Can you do work? And that's what we, that's the task to which we set ourselves all the time at Oblong. So work is important. So the first principle, we live in the real world. We live in 3 space. We live in architectural space that's designed to enfold us and to be useful at human scale. Computers, historically, on the other hand, and the pixels that they drive, do not. They live in a kind of imaginary abstract space. And I imagine that all of you have probably played with various graphical toolkits. And for every one of those toolkits, what is the set of coordinates that describes that top left pixel? 0, 0. What's the set of coordinates that describes the top left pixel here? 0, 0. That seems like a bit of a problem. We can't possibly build the kinds of systems that I was describing if we've got that kind of aliasing, that kind of overlap. And there's a very simple solution. Address each pixel by acknowledging that it's in real space and give it the name that is its x, y, z coordinate. Or, spherical coordinates if you must. But x, y, z is perfectly fine. So floating point, not integer coordinates. 3-space addressing. If stuff moves through space, then you have to track it so you can change those coordinates. But you've now disambiguated every pixel in the world. Now, we're in the space already, and we're excellent at it. We're masters of walking around and using the physical universe. We can do all sorts of things when we connect bodies and pixels that know about their real-world existence. Things like pointing become very, very easy all of a sudden because it's just a geometric calculation. But the human value of that geometric calculation is immense. So I'll show a brief set of clips of various early demos that were written in G-Speak. Here you see a bunch of wobbly letters being manipulated by pointing. Pointing is that magic human gesture. It's the geometric gesture. You do it to indicate distant objects or distant bits of space, but you do it socially. You do it for other people who can do magic vector math in their heads and know full well that I'm pointing at the E and not the P. That's pretty cool. So that's the first thing you teach the computer. The middle of the room is the one place you can stand and get at every pixel that's anywhere, right? When you get closer in, then you get touch. And between touch and free space gestures, hover. So you can use your hands like you use your hands, which is to gather and to sift and to shape. You can reach out and grab literal objects or virtual objects and pull them around and inspect them. That's the way that you understand the world in the first place. Sometimes displays move underneath the pixels, logically speaking. And sometimes, for us, pixels are physical, and they have to respect that same language, that same human gestural language. And navigation in 3 space is critically important. We've got 25 years of really gorgeous work in computer visualization. That's only serving one big part of your brain, the human visual system. The next biggest piece, or it might be bigger, is the part that's evolved to move your body through space, to understand your body's relationship with space, the haptics, the proprioception, the muscle memory. If you can engage that and clamp together those 2 hemispheres, or lobes, as it were, you have the opportunity to understand the world, the digital world, in a completely new way, in a very visceral way, and a critically important way. Second principle, aesthetics are not an option. They're not a lacquer that you put on at the end. They're actually a tool. They're a way to make things work. Stuff being beautiful isn't just pleasing, it's actually a new sense of efficacy, of agency. And in fact, you know when you get an interface right because it feels exhilarating. It feels like swimming or running or skiing. It feels like playing the piano or playing the clarinet. It feels like playing tennis. It feels like making a movie. It feels like all the things that you do in the world that involve maybe some physical motion, but also some cognitive stuff that gets you in your gut. And when you get it right, as I say, you can tell. And you can tell intuitively. You don't need your intellect to understand that it's done right, which is a very convenient metric. So this is a system we built for Sundance, the Sundance Film Festival, and for the University Art Museum at Cal State Long Beach. And this system invited people to come in, put on a pair of gloves, and scrub through movies. There's like 18 movies in here, frame for frame, and you can zip through them. But then you can take pieces out of the movies and pull them out down to a composing surface. And then you can go over to another movie that was maybe shot at a different time and in a different country and certainly was never intended to work with the first one, and you can pull more props and characters and scenography out of that and compose together a kind of collage. Now, this is fun stuff. It's sort of a museum piece. Maybe it says something about the future of media manipulation and creation. It doesn't really matter because for me, for us, it's a metaphor. It's a metaphor about agency. It's a metaphor for how powerful you should be allowed to be in relation to your own stuff, in relation to your own data, your own media. You should have fine-grained control of this sort over everything that's already yours. And the only way you can do that is through a UI, a better UI, a more capable UI. And that's what we need to build. Third principle, we're at the beginning of an enormous shift that's so close that it's not possible quite to see. We've spent the last 15 years getting very well trained by very impressive companies to love our devices, to fetishize them almost. And they're built so beautifully and so masterfully and so well that they're indeed well worth fetishizing. But is that really what we care about? Do we really care about the device? Again, this device has the weird and arbitrary limitation that everything it does, more or less, ends at its physical boundary. And there's not enough space, really, to get real work done here. This is a component of the future, but not the whole thing. What we care about, actually, is the pixels. We care about the stuff that we can see and interact with. So there is a shift coming in which we'll care far less about the device and far more about the pixels, and in particular, about the interoperability of the pixels, which no one device can own. These are some experiments that we've done recently at Oblong. When you write programs in G-Speak, this can happen. So here's 5 different displays driven by 3 different computers running 2 different operating systems. A little bit of media is running around all of those displays. They're synchronized in time and space. And when it expands, you can see that it's all behaving of a piece. And the human here gets exactly what the human expects and wants. If there's the possibility of display, if there's a pixel, then the right thing can move under it or on top of it or however you want to talk about it. And it isn't hampered by the fact that there's different operating systems, different resolutions, different display technologies. That's how the world should work. A second similar evocation here, you see a little L system tree, a bit of data being pulled from an OS X laptop to a giant screen driven by Linux. a different one being pulled back, the prime sense, i.e. connect sensor being used for large gestures. Then we come in and we manipulate the data using a leap motion sensor. So that's a new kind of multiplicity, a multiplicity of screens, multiplicity of sensors. It's not someone saying, well, the present is the mouse and the future is going to be gesture. It's all of it. That's what's new. The new understanding that you can go to the utensil drawer and you're not bewildered by the fact that there's a fork and a spoon and a knife. We're perfectly fine with that. You pick up the right tool for the task. And our computers, our computational systems will allow that as well. Final principle, back we are to work in a way. And the other enormous liability and enormous artificial limitation of computers as we understand them today is that they're hideously one-to-one. You know, the computer expects that only one person will use it at a time. And as they get smaller and smaller, of course, that becomes more and more the case. There's a generational danger there, because if we go too much longer, we'll forget to even ask if that's okay or not okay, or should we be doing something about it. Nothing impedes collaboration, collaborative work, which humans are normally very good at, like a bunch of laptops open on a meeting room table. Because each one of those is a kind of attentional wormhole that takes you out of the real world, the physical world, and takes your attention and sucks it into this abstract space. So the digital tools are somehow really, really bad at collaboration, but that can be fixed. So thus far, everything that we've looked at might be said to be either fiction or kind of academic experiment. That would be interesting, but what's much more interesting, I think, is asking the question, can all of these ideas be brought to bear today to help people, to make people's lives better, to make work more efficient and more captivating and maybe even more fun? So this is a brief video that shows Oblong's first broad market product. It's a conference room system called Mezzanine. And the idea is to take that exact problem I described out of the picture. People sitting in a room with no computers can get a lot done. They talk, they draw pictures, they debate, they discuss. And that's what the screens in a mezzanine room do. All of the pixels in here form a shared pixel workspace. And everyone in the room has access to it. Control access, manipulatory access, upload, download access through whatever device they bring in. So here's a tablet that is being used to scroll the slide deck, but can also be used as a source of data. Here's a particular image. These people are working on designing a new automobile, or maybe they're in the marketing department. That data is just thrown instantly or near instantly up into the shared pixel workspace, where it becomes available for everyone's inspection and everyone's manipulation. Similarly, here's a smaller device, a phone that has a camera built in, and Mezzanine respects whatever device characteristics there are. So taking a picture instantly injects that new data into the scene so that it can be worked on by lots of people. There's a browser client, and then you can also use this 3D control wand that you see there. Telepresence, VTC, is important. It's great to be able to talk to people, but that's rarely more than 5% of the actual work you need to get done. Here, we kind of wrap around telepresence. If you need to see people big, that's great. Then you can shrink them down and put them in the corner and get back to the real work. Here's a laptop connected to the system, and all of its pixels are recapitulated up on the screens where they can be seen. A whiteboard is a perfectly fine and adequate piece of meeting room kit. Doesn't need to become digital necessarily, but what it needs is a way for anything you do there, any work you perform there, to be pulled as a first-class citizen into the workspace, where it can become a permanent part of the record of your work activities. And again, you know, best of all, the most fun is a 3-space, 6-degree of freedom control mechanism like this wand, which is sort of a stand-in, a more hygienic stand-in for the gloves that you might otherwise wear to perform gestural computing. And what's great about that is you can drag stuff around corners. You can point at anything in the room and control it. You can also use it to recompose materials. So we've cut out a chunk of that whiteboard grab and moved it over to a side screen. But all of these things work at the same time. The UI encourages and allows and does not explode when many people are manipulating the space at the same time. And in fact, here you see the gentleman in the top left using the wand to reach through the pixels up there and control the connected laptop. So that idea is like capability syndication. You come into the room with some particular esoteric CAD program. Now you give that capability to everyone who's in the room. And then we go out past the room. We connect together different rooms. And everyone has exactly symmetric control of and view of all of the information at the same time. So it's as if you were in the same room, not just seeing each other, but looking at the same work product and building the same future. And there's the word, future. So this is the kind of stuff that we need to build in addition to all the other amazing stuff we've talked about today and that the world is already building. We need to build computational systems that are much more about us and our humanity, that are attention enhancing rather than distraction agents, that amplify our human intent. They should be like giant exoskeletons for our creativity, for our will, for our expertise, and also for our exploratory instincts. They should value meaning and not just entertainment. And they should, more than anything else, be about synthesis. We want to be not just consumers of data and media, but we want to be creators as well. And that's what we can aspire to, and I think that's what we should all build together. Thank you.